Hey everyone, welcome to the blockchain and cryptocurrency course. In this video tutorial, we will be learning about encryption and different type of encryption techniques, in which we will cover what is encryption, two types of encryption which includes symmetric encryption and asymmetric encryption or public key cryptography. We will also see what is hashing. We will also learn about digital signature. That's it. These are the things which we are going to cover in this video tutorial. So let's get started. In cryptography, encryption is the process of encoding a message or information in such a way that only authorized parties can access it, and those who are not authorized cannot. In the encryption scheme, the intended information or message, referred to as a plain text, is encrypted using an encryption algorithm called cipher, generating a ciphertext that can be read only if it is decrypted. For technical reasons, an encryption scheme usually uses a pseudo-random encryption key generated by an algorithm. It is in principle possible to decrypt the message without possessing the key. But for a well-designed encryption scheme, considerable computational resource and skills are required. An authorized recipient can easily decrypt the message with the key provided by originator to the recipient, but not an unauthorized user. Symmetric key and asymmetric key are the two primary types of encryption. Encryption is essential for ensured and trusted delivery for sensitive information. We'll be seeing both types of encryption technique. Let's start with symmetric key encryption. Now let's first understand how unencrypted message is not secure. Bob wants to send a message to Alice. For example, he is using some messaging service to send a message. So he types a message and send it over a network. In message, Bob says to Alice, send $1,000 to Eve. Alice successfully receives a message. She reads it and sends $1,000 to Eve. Message is sent successfully, but the problem occurs when third party, here is a John who is malicious person, gains access to the system and message sent by Bob. He modifies message from send $1,000 to Eve to send $2,000 to John, and then he sends it to Alice. Alice receives a message and reads it. As it is instruction from Bob, Alice sends $2,000 to John. That's why plain text messages or unencrypted messages are very unsecure. Now we know importance of security. Let's see how symmetric encryption works. In symmetric encryption, both party shares one secret key. That secret key is used to encrypt plain text using some algorithm, and same key is used to decrypt the message. Now the question is how they share this key. If they send key by message or email, if someone gain access to this key, then he or she can encrypt or decrypt all the messages. So they arrange a personal meeting and shares a secret key with each other, and both party keeps key at a secure place. Now whenever Bob wants to send a message to Alice, he encrypts his message with the key, produces a ciphertext using some algorithm. Now John, who is a malicious person, gains access into messaging system and accesses message, but he can't read anything because it's encrypted. He doesn't have a secret key, so he can't decrypt a message, so he can't read messages. On other side, Alice receives message and decrypts message using secret key, and she can read message. So this is how symmetric encryption can transfer data securely. But as I said earlier, it is possible to derive secret key when highly skilled people and enough processing or computing power available. Because key is nothing but a random string, and by trying more and more permutation, someone can derive key. So this is symmetric encryption. Public key cryptography or asymmetric cryptography is a cryptographic system that uses pairs of key. Public key which may be disseminated widely, and private key which are known only to owner. The generation of such key depends on cryptographic algorithm based on mathematical problem to produce one-way function. Effective security only requires keeping the private key private. The public key can openly distributed without compromising security. In such system, any person can encrypt message using receiver's public key, but that encrypted message can only be decrypted with the receiver's private key. So in this case, Bob generates pair of key using some algorithm. RSA is one of the popular and secure public key cryptography algorithm. So now Bob has two keys. One is private key and second one is public key. Same way, Alice also generates pair of key. In symmetric encryption, it was not safe to share secret key. When using asymmetric encryption, both parties can share their public key to each other or to the world. So now, if Bob wants to send message to Alice, he encrypts message with Alice's public key and sends message. If John tries to decrypt message, he won't be able to because he doesn't have private key of Alice. Alice receives encrypted message and she will decrypt message with her private key. Both keys are related to each other, still it can't be derived from other key. So asymmetric encryption is more secure. So this is how asymmetric encryption works. Now let's talk about hashing. A hash function is any function that can be used to map data of arbitrary size onto data of fixed size. The values written by hash function are called hash values, hash codes, digest or simply hashes. Hash functions are often used in combination with hash table, a common data structure used in computer software for rapid data lookup. A cryptographic hash function allows one to easily verify whether some input data mapped onto a given hash value. But if the input data is unknown, it is deliberately difficult to reconstruct it by knowing the stored hash value. This is used for assuring integrity of transmitted data, and this is the building block of HMACs, which provide message authentication. The hash function is used to index the original value or key, then used later each time the data associated with the value or key is to be retrieved. Thus, hashing is always a one-way operation. There is no need to reverse engineer the hash function by analyzing the hashed value. In fact, the ideal hash function can't be derived by such analysis. A good hash function also should not produce the same hash value from two different inputs. If it does, this is known as collision. A hash function that offers an extremely low risk of collision may be considered as acceptable. Hash functions are used widely in cryptography and blockchain. Digital signatures are based on asymmetric cryptography and can provide assurance of evidence to origin, identity and status of an electric document, transaction or message, as well as acknowledging informed consent by signer. To create digital signature, signing software creates a one-way hash of the electronic data to be signed. The user's private key is then used to encrypt the hash, returning a value that is unique to hashed data. The encrypted hash along with the other information such as the hashing algorithm forms a digital signature. Any change in the data, even to the single bit, results in a different hash value. This attribute enables others to validate integrity of the data by using signer's public key to decrypt the hash. If the decrypted hash matches a second computed hash of the same data, it proves that the data hasn't changed since it was signed. If the two hashes don't match, the data has either been tampered with in some way or the signature was created with private key that doesn't correspond to the public key represented by the signer. A digital signature also makes it difficult for signing party to deny having signed something. If the signing party denies a valid digital signature, their private key either been compromised or they are being untruthful. In many countries, including the United States, digital signature have same legal weight as more traditional forms of signatures. So let's quickly revise what we have seen in this tutorial. We have learned about encryption, two types of encryption, symmetric encryption and asymmetric encryption, what is hashing and how it works, how we can produce digital signature and how it can be used. So this was very important tutorial for this course because public key cryptography is widely used in cryptocurrency and blockchain. So this is all about encryption and public key cryptography. See you in next video. Thank you very much.